Welcome back to the second episode of the Sedrica Series. Today we are going to talk about the localization subsystem. Why do we use a GPS while driving? It is to get the position of the car in its environment. Did you know that a GPS will generally give an error of 1 to 10 meters? While such an error is okay in a normal car, even the slightest error can prove fatal in a self-driving car. We can drive the car independently only if we locate it accurately. That is where localization comes in. It is the process of pinpointing the car's location within centimeters on a map. The high accuracy is needed to sense the road and lane structures, the forking and merging of lanes, and to plan lane changes even in the absence of lane markings. Localization can be carried out by many techniques. The first is odometry. Odometry uses the car's starting position and calculates the displacement of the wheel to find its position. This method is not very accurate and leads to a buildup of errors. Another popular method is SLAM, which estimates the coordinates of the car and the landmarks on the map. It is used for outdoor and indoor navigation where GPS is not very effective. Localization is a constantly evolving subject with more accurate and efficient algorithms for sensors still being made. As the localization subsystem of Sedrica, we take input from sensors and give the map and position of the car to the motion planning subsystem. Last summer, we made a map of the institute using SLAM and localized our vehicle with up to 20 centimeter accuracy. We are currently working on implementing the Kalman filter, another localization technique for GPS and IMU data for the upcoming IGVC of 2023. That was all about the localization subsystem. Stay tuned for the next episode of the Sedrica Series.